Hi and welcome to this IB Maths Intense video on our third topic, geometry and trigonometry. This set of videos we're looking at working with simple triangles and just some basic work on simple trigonometrical ratios. For a lot of you, this is a topic that you will already have seen in your prior learning in maths before you started the IB course. So it should just serve as a recap, or you can skip very quickly to the end if this is something you're very familiar with. But it's worth just having an introductory video for those who haven't seen this before, or just to remind those of you if you haven't seen this for a while. This is on the IB specification. There's SL 3.2, use of sine, cosine and tan ratios to find the sides and angles of right angle triangles. So let's do a quick recap then on how these three ratios work with right angle triangles. So as a starting point is the principle that we looked at in an earlier video, which is about similar triangles. And here is a nice simple isosceles right angle triangle, two angles of 45 degrees and a right angle of 90. And I've said the two sides, they're both equal because it's an isosceles triangle, have length of 1 centimetre. So we know the length of the hypotenuse there as well. Using Pythagoras, it would be the square root of 1 squared plus 1 squared, which is the square root of 2. So I can label that missing side, the hypotenuse, is root 2 centimetres. Now, if I enlarge this triangle, nothing happens to the two angles. They stay as 45 degrees, and the two sides have now been doubled. They're both 2 centimetres in length. They stay in proportion because they're similar triangles. And similarly, the hypotenuse, the square root of 2 squared plus 2 squared, square root of 8, which is now 2 root 2 centimetres. So what we can see from this little example is that the angles have stayed the same in the triangle, even though I've doubled all the sides. And we can also see that when the angle is 45 degrees here, down in the bottom left-hand corner, the relationship between the sides stays the same. So the two non-hypotenuse sides remain the same. Their ratio is 1 to 1, 2 to 2, 5 to 5, whatever the sides of the triangle would be. And similarly, the relationship between each of the sides and the hypotenuse stays the same. So in the smaller triangle, the ratio is 1 centimetre to root 2 centimetre. And in this larger enlargement, the ratio is 2 to 2 root 2, which is, if I simplify it, the same. It's 1 to root 2. So with similar triangles, the relationship between the size of the sides stays the same when the angles are the same in the triangle. It doesn't matter how big the triangle is in terms of its enlargement. If the angle stays the same, the relationship between the adjacent, the opposite and the hypotenuse will always stay the same. And these are encapsulated in our three trig ratios. Really important when you're dealing with right angle triangles is if you're interested or given an angle, in this case I've labelled it as theta, that you need to be able to always label your three sides of the triangle correctly. Now the hypotenuse is always easy to label. It's always the longest side of the right angle triangle. The longest side is always opposite the right angle. It's the hypotenuse. The opposite side of the triangle is always the side opposite to where the angle resides. So the angle down here is in the bottom left-hand corner. So the opposite side is going to be the side which effectively doesn't touch the angle at all. It's on the opposite side of the triangle. And the adjacent side, the word adjacent means next to, is the side that forms the angle with the hypotenuse. It's adjacent, it's touching, it's next to. And as you can see, there are three different relationships between sides for this particular angle theta. We've got the relationship between the opposite side and the hypotenuse. We've also got the relationship between the adjacent side and the hypotenuse. And then we've got the relationship between the opposite side and the adjacent side. So there are three different ratios, or three different ways of describing the relationship between the sides in this triangle for an angle of theta. And those are the three ratios that we give names to. So the first one, the relationship between the opposite and the hypotenuse side, is called the sine ratio. So sine theta is the relationship between the opposite and the hypotenuse. The cosine ratio, cos theta, is the relationship between the adjacent side and the hypotenuse. And tan theta, tangent ratio, is the relationship between the opposite side and the adjacent side. So really critical that you can label the sides correctly so you know which particular ratio is the one that's going to be useful to you in finding out more about this triangle. Let's do a few simple examples just to show you how to work out missing sides and how to find out missing angles using the appropriate ratios in a right-angled triangle. So here's a nice empty triangle. Let's first of all use this to work out some missing sides. So let's imagine this angle here is 35 degrees, and let's imagine that I know that this side is 8 centimetres. And I want to work out the length of the hypotenuse. Now, I need to know that in this triangle, 8 centimetres is which side? It's the opposite side. And the hypotenuse is over here. So I know that I've got the opposite side and the hypotenuse, and I've got the angle. And if I look, I can see that this, the sine ratio is the ratio that will help me when I've got that combination. I've got an angle, I've got the opposite side, but I want the hypotenuse. And I know that my ratio tells me that sine 35 is equal to the opposite side, which is 8, over the hypotenuse. And I can rearrange that, and the little triangle that I've shown you down in the bottom right-hand corner tells me easily how to rearrange if I find rearranging fractions like that to be difficult. I'm interested in the hypotenuse, and you can see my little triangle here says the hypotenuse is equal to the way that these are formed tells me it's the opposite side divided by the sine of the angle. So my hypotenuse is equal to the opposite side, 8 over sine 35. And if I work that out in my calculator, then 8 over sine 35 equals 13.95 centimetres. And I can check, does that make sense? The hypotenuse is the longest side. So yes, that looks like it would be right, 13.95. Great. Now, if I didn't want to find out one of the lengths of a side, but I wanted to find the missing angle, imagine that I knew that this side, let's label some different sides, maybe this is 6 centimetres, and this is 10 centimetres, and I'm interested in this angle down here, theta, which I don't know what it is. But still, if I have labelled my sides correctly, I know that I've got the opposite side here, and I've got the hypotenuse here. So it's going to be the sine ratio that is going to help me to find out about the missing angle here, theta. So again, I can write down sine theta is equal to the opposite side, 6, over the hypotenuse, 10, so 0.6. Now, unfortunately, that doesn't tell me what the angle is. It just tells me the sine of the angle that I'm interested in would be equal to 0.6. The ratio between the opposite and the hypotenuse would be 0.6. Now, on my calculator, I can then use that information to find the size of the missing angle just by using the function on your calculator, sine to the minus 1 of 0.6, the inverse sine ratio, sine to minus 1 of 0.6, and that will then work backwards to tell me the missing angle, which is 36.787 degrees. Now, I'm working here on my calculator in degrees because we're working with right-angled triangles, and our common currency for right-angled triangles is degrees. Later on in the course here, I'm going to introduce you to the unit of measurement called radians for angles, but at the moment we're just going to stick with degrees. Make sure your calculator is in degrees mode. So let's just use a different ratio this time. So that's the circumstance for using the sine ratio is when we've got information about an angle and the opposite and the hypotenuse. Usually one of the three is missing that we want, but we can use the other two to find it. So here, let's label a different side just to show you. It doesn't always have to be the angle down in the bottom left-hand corner. Maybe here, up on the right-hand corner, the angle's 50 degrees, and maybe I know the hypotenuse is 10 centimeters, and I'm interested in this side here, which is the adjacent side. It's the hypotenuse is always the hypotenuse, and you can see that over here with the x, this would be the opposite side this time because it's not touching the angle, and the one that I've labelled adjacent is the adjacent side. So how can I find the adjacent side? This time I've got the angle, I want the adjacent side, and I've been given the hypotenuse, so I would use the cosine ratio because that's a ratio that describes the relationship between the adjacent side and the hypotenuse. And here I would write down, cosine 50 is equal to my adjacent side over the hypotenuse. Now if I want to which is equal to the adjacent side over 10. Down in the bottom right hand corner, how to rearrange. If I want the adjacent side, this time I would take the cosine of the angle and multiply it by the hypotenuse. That's the way that these three symbols are formed tells me whether I need to divide or multiply. So the adjacent is equal to the cosine times the hypotenuse. So here, my adjacent side would be equal to 10 times cosine 50, which I can work out on my calculator, and that will give me an adjacent side of 6.42 centimeters. So nice and straightforward when I'm finding a missing side. Let's just do another example, this time where I'm going to find the missing angle. So that angle of 50 degrees, we'll get rid of that. And this time, let's put some values in for our two sides. Maybe this time my adjacent side is 5 centimeters and my hypotenuse is 12. And theta there's the angle that I want to find. So I can write down what I know. I know that the cosine of theta would be equal to the adjacent side, which is 5, divided by the hypotenuse, which is 12. But that doesn't tell me the size of the angle, it just tells me what the ratio for that angle would be. So on my calculator, I would need to do the inverse cosine of 5 over 12, and that would tell me the missing angle. My calculator tells me the angle is 65.38 degrees. And then finally, we have the third ratio, which is the tan ratio. Now, the tangent ratio is all about the relationship between the opposite side and the adjacent side. So let's this time work with an angle down in this corner, and my adjacent side is the one touching. Let's assume that that's here, but I don't know the value. And the opposite side, let's say that's 5 centimeters. So if I wanted to find the adjacent side, well, I know that tan 40 is equal to the opposite side, 5, over the adjacent side. Down in the bottom right-hand corner, if I want to rearrange that, and I'm not comfortable with doing that, I can use the little triangle, and it tells me the adjacent side is equal to the opposite side divided by the tan of the angle. So adjacent equals, this time, opposite 5 divided by tan 40. I do that on my calculator. 5 over tan 40 is 5.96 centimeters. So that would be my adjacent side. Let's do one more example for good measure. This time I'm going to try and find out the missing angle. We can stick with that one down in the bottom left-hand corner. Let's get rid of the working. Previous example. So label my angle as theta. I don't know what it is, but I know that the two sides here, let's say my opposite side is 6 centimeters and my adjacent side is 9 centimeters. So again, I know that I've got opposite and adjacent sides here, so this must be the tan ratio that's interesting. So tan theta is equal to the opposite divided by the adjacent. But that doesn't tell me the angle, it just tells me what the ratio for the angle is. So on my calculator, I would do the inverse tan ratio of 6/9, and that would tell me my missing angle, which is 33.69 degrees. So those are the three ratios, and it's all about knowing what are the three variables that you are working with. There will be an angle, and then there will be two other sides, and the two sides will tell you whether to use sine, cosine, or tangent. There they are encapsulated in those three triangles, which are useful because they help you to rearrange given the information you have. So your routine should be, if you are given some information, let's say you were given an angle here of 52 degrees, and you were given a hypotenuse of, let's say this is 10 centimeters. If you wanted to find this side here, well, what information have we got? We've got an angle, we've got a hypotenuse, and we want to find the opposite side. So I look at my three ratios here. Which of them has got the opposite and the hypotenuse in it? Well, there it is. It's going to be the sine ratio. If I wanted to find maybe this side here, which is the adjacent side, now I've got the adjacent and the hypotenuse, well, I would then be looking at the cosine ratio. And similarly, if I had this side here, 7 centimeters, and I didn't have the hypotenuse, now I've got the adjacent side is what I want, and I've been given the opposite, well, then I could use the tan ratio to find that particular solution. There. And that's how we use the right ratio to find the missing sides. Always make sure when you are working with a right angle triangle that if you're, let's say we're working with this angle up here, make sure you label the sides. This is the hypotenuse, this is the adjacent, and this is the opposite. And that would be our key. Okay, so that's how we work with simple trig ratios in degrees for right angle triangles. It's just about choosing the right ratio, and you can work out a missing side, or you can use the ratio of the two sides to find the missing angle as well. I hope you found that useful. Thank you for watching. Don't forget to like this video and subscribe to my YouTube channel, IB Maths Intense. Tell your friends I'm here. Drop me an email, ibmathsintense@gmail.com, if there's anything you'd like to see or if you've spotted any mistakes. In the meantime, stay healthy and enjoy your maths.